So on your first slide here, you have your daily quiz. There are 3 questions from the worksheet that you did yesterday. So on the first question, you're finding the cosine of angle Z, the tangent of angle X, and the sine of angle Z. Now, this question on your worksheet yesterday, they only asked you to find one value. I'm asking you to find 3 today, just to show me you can find sine, cosine, and tangent. Number 2, you're calculating in your calculator. And number 3, you are answering a question about the sine and the cosine of those 2 angles. Once you have finished your daily quiz, you can move on to the lesson for today. So today what we are going to look at is using those trig ratios that we wrote yesterday to actually solve equations that involve trig functions. Now, for our main objective for today, we are going to be able to solve equations involving right triangle trig. So pretty straightforward what we are going to be looking at. Nothing too tricky, and our objective is going to be pretty straight and to the point. Now, real quick before we get too far into our lesson for today, please make sure, because you have a new calculator today, and remember I told you yesterday that you have to make sure that the mode is set up correctly in your calculator. So before you start anything in your calculator, I want you to go to the mode menu. It is the button at the not at the very top, but at the top of your group of buttons there. It's not up by the graphing stuff, and it is next to where it says second. So next to the second button, you'll see mode. Please make sure that your calculator is in degrees, not in radians. And I showed you how to do this yesterday, so make sure that that calculator is set in degrees, not in radians. So by the end of the day today, you are going to be able to solve these 2 questions. So when you finish your lesson, your mastery ticket will appear again at the end of the lesson. But if you look at your 2 questions that you have here, I know that it says solve each equation for X at the top. I forgot to change that because one of these is actually W. So obviously in this question, you're actually solving for W. But you will be able to, by the end of class today, figure out how do I write an equation to solve for that missing variable in the problem. So when we are talking about trig equations and being able to solve equations using trig here, the first thing that you need to know is that for today we're only going to be solving for missing side measures. We will deal with missing angle measures tomorrow because the equations are set up just a little bit differently. So in your first bullet there, it says to find a missing side measure in a right triangle, you will set up equations using the trig ratios that we just talked about yesterday. So we had talked about SOHCAHTOA yesterday and the relationships between your sine and the opposite and hypotenuse, your cosine being the adjacent and hypotenuse, and tangent being opposite and adjacent. We talked about the relationship of these 3 trig functions and also the relationship between the opposite, the adjacent, and the hypotenuse in the right triangle. So we are going to be using that idea again today when we are setting up our equations. So I wanted to make sure we review SOHCAHTOA. I will be writing that on the top of each one of our slides today. And I encourage you to write that as many times as possible because, like I said yesterday, that is not on the formula sheet for 10 Ready, and you're going to have quite a few trig questions on the 10 Ready test, as you saw on that missed practice test you took last week. So just as a reminder, when you are writing your 3 trig functions, and this is the format that your equations are going to be in, your sine, cosine, or tangent is always being taken of the angle. So when I'm talking about X in this case, X is going to actually represent the angle in your problem, not the variable X. X is an angle measure. So wherever your angle measure is, or whatever your angle measure is, that is what is always going to go with your sine, your cosine, or your tangent. Now, your ratio that is on the other side is going to be dependent on what is in your triangle and whether you are actually using a sine, a cosine, or a tangent function. So let's take a look at some examples and I will explain how to set up our equations here. So looking at number 1, it says find the value of X and round to the nearest tenth. So what we are going to do here is we are going to be setting up a trig equation. So the first thing that you need to know is that you are following pretty much the same first couple steps that you did yesterday. So when we were identifying our trig values, when we were writing our trig ratios yesterday, the very first step that we did is that we had to identify our reference angle in the problem. That is still, anytime you are dealing with a trig question, you have to identify the reference angle first. It doesn't doesn't matter whether you are solving for a missing side, solving for a missing angle, or just writing a basic ratio. The first thing that you want to do is identify that reference angle. Now, the reference angle is the angle that you are given in the problem. So for this particular problem, my reference angle is going to be the 33 degrees. Now, remember the importance of why you identify that angle first is that determines where your sides are or what your sides are labeled. So it determines with relation to that reference angle, where are they located, which determines how we label them opposite, adjacent, and hypotenuse. So looking at my side measures, I notice that the 14 is opposite the right angle here. My 14 is in fact the longest side. This is my hypotenuse in the triangle because it is opposite the right angle there. And what I also notice is that the x is directly opposite the 33 degrees. So you will notice that I only labeled the two sides that I was given in the problem. I don't care what side this is. This side is not going to help me because there is no value given to me on that side. That side of the triangle is not going to help me solve this problem in any way. So I have identified the two pieces that I am given as being opposite because it is directly opposite the reference angle, and hypotenuse because this is across from the right angle here. Now, the reason that we only want to identify the sides that we are given in the problem is that those are the sides that determine which trig function you are using for this problem. So what I'm going to do at the top here is I've gotten to the point where I've got to determine which trig function is appropriate. So on the very top, I'm going to rewrite my SOHCAHTOA so that I can determine which trig function I am going to use for this particular problem. Now, I notice with opposite and hypotenuse that opposite and hypotenuse represents a sine function. So I am definitely going to be using my sine function here. So I am going to write my sine equation. Now, sine is represented, a sine equation is written as sine of x is equal to opposite over hypotenuse. And in this case, remember that x represents the angle measure in your problem. It doesn't represent the actual x in your problem. So let's go ahead and let's plug everything in. I need an angle measure, I need an opposite, and I need a hypotenuse. So let's go ahead and plug those in. So I have sine of 33, because my angle measure is 33 degrees, is equal to my opposite was x, and my hypotenuse was 14. So all I did was take my three values and I plugged them in appropriately into my equation here. So my angle measure went in for x, my opposite went in for my opposite here, and my hypotenuse went in for hypotenuse. Now, once you have the equation set up, I need to get x by itself. And I notice that my x is right here in the numerator of this fraction. So what I need to do is I need to get rid of this 14 that is in the denominator. So what I notice is that this is an equation, and I've got two sides to every equation. And if I want to get x by itself, I need to get this 14 to the other side somehow. Now, what I noticed is on the right-hand side that I was dividing by 14. This is divided by 14. The opposite of dividing by 14 would be multiplying by 14. So I'm going to come over here and I'm going to do times 14. Now, when I multiply that 14 to the other side, it gets rid of that 14 in the denominator. Now, I'm at the point where I have gotten x by itself on the right-hand side, but I need to calculate this value over here on the left-hand side. Now, one of the things that I want to caution you about, you have to be very careful, and this is why I kind of pushed this yesterday in the lesson. When you go to put this in the calculator, remember that the calculator opens a parenthesis right there. When you push sine, it automatically opens a parenthesis. When you put the 33 in, if you do not close the parenthesis before you multiply by 14, you will get the wrong answer on every single one of these questions. So please make sure that you are actually paying attention when you put this in the calculator, because if you forget that one step, you get every trig question wrong for the remainder of this module. So please make sure you're paying attention to that. So what I'm going to put in my calculator, I'm going to press the sine button. I'm going to put in 33, I'm going to close my parenthesis, and I'm going to do times 14. So I'm just doing sine of 33 times 14, which ends up being approximately 7.6, and it said round to the nearest tenth, so that's just 7.6. Oh, it would help if I switch back to my pen. So x is equal to 7.6 here. Now, if you are not getting 7.6 in your calculator, please let me know. Please don't just let me do these all on the screen and then you go to try to practice one on your own and you have no idea how to put it in your calculator. Using the sine, cosine, and tangent in your calculator is very new, so please make sure you are actually practicing your calculator skills as well, because you don't want to know how to solve this on the 10 ready test but don't know how to put it in your calculator and you can't ask anybody. So make sure that you're working along with me. All right, so let's talk about number 2 here. And in number 2, remember that the first thing that we need to do is identify our reference angle in the problem. So I have found that my reference angle is right here. It's the 37 degrees that is labeled. Your reference angle will always be the one that is just labeled with a degree measure there. And remember that your reference angle cannot be the right angle. So you will have at least one of the other two angles measured or labeled with a measure there. Now, up at the top, I'm going to add my SOHCAHTOA so I can determine which function will be appropriate here. Now, looking at my triangle, I'm looking to determine where my opposite, my adjacent, and my hypotenuse are. Now, I notice that the 14 is across from the right angle, so that 14 has to be my hypotenuse. And I also notice that the x actually touches my reference angle. Now, if I'm thinking opposite versus adjacent here, I know that the opposite side should be across the triangle from my reference angle. This x is not across the triangle. This x is actually touching the reference angle. The word adjacent literally means next to or touching. So I know that my x here is going to be my adjacent side. So looking at the two pieces that I have my adjacent and I have my hypotenuse. So I notice that adjacent and hypotenuse is a cosine function. So I'm definitely going to be using my cosine here. So writing my trig equation, I have cosine of x is equal to adjacent over hypotenuse. Now, I know that x represents my angle measure, the adjacent represents the adjacent side, and the hypotenuse represents my hypotenuse. So let's go ahead and start plugging those values in. I have cosine of 37, my angle measure is 37, and my adjacent is x, and my hypotenuse is 14. Now, once again, I've got my equation written and I want to solve for x. So I noticed that I do have, and that line wasn't very straight, sorry about that. I do have two sides of my equation here, and I do know that in order to get my x by itself, I do need to move this 14 over to the other side. Now, right now, what I have is divided by 14. So I know that the opposite of dividing by 14 is multiplying by 14. So I'm going to go ahead and multiply that 14 to the other side. Now, that takes the 14 away from this side. So on the left-hand side, I'm left with, or on the right-hand side this time, I'm on the right-hand side, I'm left with x. And on the left-hand side, when I go to put this in my calculator, remember I told you, you've got to be super careful when you put this in your calculator. Make sure you close that parenthesis after the 37. So I'm going to do cosine of 37, close parenthesis, times 14. And I end up with approximately 11.2. Now, next up, number 3. This one tends to be one of the harder questions for students to answer because the triangle has actually been rotated. So a lot of students get tripped up with looking at this figure because they go to try to label the opposite, the adjacent, and the hypotenuse, and it's all messed up because the triangle has been rotated. The other thing that messes students up is the fact that the reference angle, they couldn't fit it in the angle here, so they drew an arrow. So that also messes students up on this question. So there's a couple things in this question that can throw you off a little bit, but let's take a look at it. First thing I'm going to do is I'm going to identify my reference angle. Now, once again, I told you that they couldn't fit the reference angle measure in there, so they drew an arrow showing you where the reference angle is supposed to go. So that angle in there, in the bottom corner there, is 29 degrees, so that's my reference angle. Next up, I'm going to identify my sides as opposite, adjacent, or hypotenuse. Now, I notice for the x that the x is clear on the other side of the triangle. So if I am going across the triangle from my reference angle, across would be on the opposite side of the triangle. So that is my opposite. Now, what I notice is that here is my right angle, and across from my right angle would be this side here. I do not know how long that side is, so I do not have my hypotenuse. So this side here touches the reference angle and is not my hypotenuse, so this would have to be my adjacent side here. So up at the top, I'm going to add my SOHCAHTOA here so that I can determine which one is appropriate. And I notice that I have opposite and adjacent here. So I have my opposite and my adjacent, which leads me to a tangent function here. So I know that I am going to be writing a tangent equation. So writing my equation, the general equation would be tangent of x is equal to opposite over adjacent. And I'm just using my TOA here, my opposite over adjacent, to actually write this. You don't have to memorize this right here. What you have to memorize is the SOHCAHTOA, because that's what tells you what values go where on here. So I've got my SOHCAHTOA written there. Now, once I have my tangent equation written out, it's just a matter of plugging my values in. So I have tangent of my angle, which is 29 degrees, is equal to the opposite was x and the adjacent was 5.4. Now, I've got my equation set up, but I know that this 5.4 can't stay on the right-hand side. It's got to move over to the left. That 5.4 is being divided, so the opposite of dividing by 5.4 would be to multiply by 5.4. So I'm going to get rid of that 5.4 on the right-hand side there. That leaves me with just x. And then in my calculator, I'm going to be real careful when I put my tangent in. I'm going to make sure I close those parentheses. So I'm going to do tangent of 29, close parentheses, times 5.4. And I end up with approximately 2.99, and I'm going to leave that as 2.99. I really don't want to round that up to 3. I don't like rounding up unless all the way up to the next whole number, unless I absolutely have to. So if it was 2.999999, then I would round up to 3, but because it's 2.993, I really don't want to round that up, so I'm going to leave that as 2.99. All right, now I'm going to leave you with number 4 as a you-do question. If you have any questions on this one, please let me know. I am going to work this one out on the video. I'm not going to be talking as I work it out because this is a you-do question, so I just want you to be able to check your answer if you need to. But at this point, I would like you to pause your video, try to work through number 4. There is one more example, so please don't stop the video, and number 5 is a little bit different than the other ones, so please make sure you watch number 5, but I want you to try this one on your own, and I am going to work this out on the screen so you can press play again when you're done and check your answer. Now, on your last question that you have here, we're going to find that something different happens on this problem. The general process is the same, which is the reason I only do one of these examples, but the way that you get your final answer is actually just a little bit different. So you've got to be careful on these questions. So first thing that I'm going to do here is same as before. I'm going to identify my reference angle, and then I'm going to identify which pieces I have. Now, I notice that the x is across from the right angle, so this is definitely my hypotenuse. And then I notice that the 9 touches the reference angle, so it cannot be opposite because the opposite side would not touch the reference angle. I also know that the word adjacent means next to or touching, so I know that the 9 has to be the adjacent side. Now, thinking about my SOHCAHTOA, I have adjacent and I have hypotenuse, so that tells me I absolutely have a cosine function here. Now, I am going to write out my cosine equation. Cosine of x is equal to adjacent over hypotenuse. Now, this is where you need to be careful because I have students that try to write the trig equations the same every single time. There is one case when they come out working a little bit differently, and you're going to see why in a minute. So let's start plugging into our cosine equation here. I have cosine of the equation, or the angle measure, not cosine of the equation, but cosine of the angle measure is 61, cosine of 61. And then when I go to plug in for adjacent and hypotenuse, my adjacent is 9 and my hypotenuse is x, so I have 9 over x. Now, that's where the difference occurs. What you should have noticed was that instead of having x over 9, I now have 9 over x. I have students that write every single trig equation the same because they don't pay attention to the difference of where everything is in the figure. It's not always x over whatever. Sometimes the number is on the top and the variable is on the bottom. So you've got to be careful when you're writing. Make sure you're paying attention. That's why I write this step out right here. I don't write that for no reason. I make sure that I have my adjacent on the top and the hypotenuse on the bottom because that is the order of the trig ratio. These are all in order. So is opposite over hypotenuse. Cosine is always adjacent over hypotenuse. Tangent is always opposite over adjacent. You can't switch those. So that's why you have to be careful. Now, in this problem, we have a little bit of a struggle because the x is in the denominator. I can't just take my 9 and multiply it to the other side like I did in the previous problem. But what I do notice is I have the beginnings of a proportion here. And a proportion is basically two fractions that are equal to each other. So what I'm going to do is I'm going to make a full proportion. Now, I want a fraction on this side. You can make a fraction out of any value by putting a 1 under it, because dividing by 1 we know does not change that value. Anything divided by 1 is itself. So what I've done is I've created a proportion here, two fractions equal to each other. We've been working with proportions for how many weeks now? Almost everything in Module 4 was proportions. We saw proportions again a little bit in Module 5, and we've just seen them in the first section here, so the section that you did on Monday. Now, we know that when we have a proportion, we need to cross multiply, so that's what we're going to do. We're going to cross multiply. So when I cross multiply in this direction, I have x cosine of 61, and I just always put the x out in front when I'm dealing with a trig function. You don't want anything behind a trig function there. You don't want cosine of 61x. It gets all messy. So x cosine of 61, and then cross multiply in the other direction, and 1 times 9 is 9. Now, once I have everything cross multiplied, I need to get x by itself, so I need to move this cosine to the other side. Now, x is being multiplied by the cosine of 61. So all I'm going to do is I'm going to divide both sides by cosine of 61 in order to get rid of that cosine of 61. So this cancels on this side, and I am left with x is equal to, and in my calculator I'm going to put 9 divided by cosine of 61, I'm putting it in exactly as it looks here. 9 divided by cosine of 61, close my parentheses, and I get approximately 18.6. So be careful and make sure you're paying attention to where your x values are and where your numbers are. Make sure that you set up your proportion in the right order. You set up your ratio here in the right order. Now, you have your Math Tray ticket here at the end, and you will notice that you now know how to solve these two questions here. Be careful, because of course I gave you one that is like the first couple questions, and I gave you one that's like the last question, number 5. So make sure you pay attention to where your variable is supposed to be when you identify your sides. Make sure that you are setting up your proportion in the correct order.